I'm Alex Rich, and I'm going to talk you as quickly as I can through my semester project for INLS625. What we're going to talk through today is a scandal involving a company called Insys, who engaged in an illegal pay-to-prescribe scheme for a sublingual fentanyl, which is essentially the nuclear weapon of opioids in America. Fentanyl has emerged as a significant killer of Americans because it is unbelievably potent and unbelievably dangerous. And what we're going to talk through is this company, Insys, who for about 4 years had only one approved drug, which was a spray under the tongue fentanyl that was approved only for cancer patients with breakthrough pain over and above their long-term opioid prescriptions. Should have been a small market. Insys made it a big market illegally. And in doing so, they tripled their stock valuation with a single approved drug. And what it was proved later that they had done was cause doctors to overprescribe to patients who didn't need the drug in exchange for money. So the objective here for me was to go through and evaluate the characteristics of the doctors who took money to prescribe excessive amounts of this drug to see if we could build a model to predict the next scandal like this coming. The challenge here is that Medicare makes available data about doctors prescribing and doctors procedural billing, and they also make available data on all of the payments from pharmaceutical companies to doctors, but intentionally, the way that the law was written when the ACA was passed, there is no identifier number for the doctors in the payments data, and so you're not supposed to be able to stitch these databases together. The challenge for me was to find a way to do that. And ultimately, I did. We're going to talk a little bit about how I did that. The analytical strategy was to go through Medicare Part D prescribing data and pull down for the entire data set available, 2013 through 2016, all the doctors who prescribed Insys' fentanyl. Then to go through each of the payments on the data set 2013 through 2017 and look at every doctor who took money from Insys. Then, the trick is to geocode the addresses associated with each address, with each data set, and then to use fuzzy matching inside Python. It's a package that you can download on the names of the physicians in each data set, and to use an algorithmic distance monitoring function on the geocoded addresses for each data set to be able to stitch them together. After I was successful in doing that, I created a category as the target attribute for a machine learning project called what I called rock stars. Folks who took more than $20,000 from Insys and prescribed more than $200,000 of their drug to Medicare Part D patients. After I did that, the idea was to mix a set of attributes from Medicare Part B and Medicare Part D into a matrix that I could put into Weka to try to build a predictive model that might give us an insight in the future as to which doctors might be susceptible to the same kind of scheme that Insys committed. So with that in mind, I'll talk you through a little bit of the underlying analysis that led up to it. This was, to me, the most visually interesting of the outcomes that I developed. This is all of the doctors who took money from Insys in red, with dots sized to the amount of money that they took, and the amount of Insys' drug that they prescribed in blue. And this is an interactive map that you can zoom in on, and so you can see the most significant of Insys' partners here, a guy named Dr. Gavin Auerbach, who is now in prison for having taken almost $40,000 from Insys to prescribe more than $10 million of this drug to patients. Pretty big deal. After I was able to do that, I started looking through the data in terms of, the way that money going to doctors and doctors prescribing interacted. And what I came down to was that kind of $200,000 prescribing and $20,000 taking threshold to define that rock star category. And when you look through the way that all that worked, you can do a bunch of visual things to see that there's just something fundamentally different about these doctors taking. And there's this whole category of doctors who took high volume of payments to do high volume of prescribing. And so what I really wanted to do was detect that and build a model to be able to see it coming. Through Weka, I had a little bit of a technical hiccup in that I needed to be able to make my target attribute a categorical rather than a numeric value. So to do that, I went through Weka, absorbed a file as a CSV, ejected it as an ARF file, and then opened it up with a text editor to be able to change the type of the attribute to this curly bracketed categorical rather than a numeric. And that enabled me to be able to run Weka models to try to build a predictive analytic capacity on this. Unfortunately, the best I could do with Weka, running all kinds of models, all kinds of bootstrapping, everything that I could think of, ultimately multinomial naive Bayes came out to be the best result for me. And even with the best I was able to do, only came out to a precision number for positive prediction of 0.506 and a recall of 0.612. So we get a ROC area under the curve of 0.653, which is, fair to mediocre at best. We're certainly not to where we need to be in terms of predictive capacity here, but we are about 20% better than just stochastic prediction based on the number of doctors who qualified as rockstar from the ingoing data set. So making progress, but not at all where I need to be. I'm going to continue working on this because I think it's important and because I think that there is a needle inside this haystack. If you're interested in it, I'm alex.rich@unc.edu, and I'd love to talk to you about the work that I'm continuing to do. Thanks very much.